Hello everyone. As part of the homework assignment, we're going to perform an incremental load on two tables and the AdventureWorks Basics data warehouse. So the two tables are customers and products. Now you have to modify the customer and products dimension tables in order for this to work. And what that means is that you're going to have to add some type 2 columns. And this is difficult. You have to write code for this to work, and the code is well advanced. So what I've done is I've created this video to kind of help with that, and a script that will give you a partial answer to the assignment. Let's see, actually, in this case, assignment partial answer. So to get that to work, I'm going to first of all go ahead and create this AdventureWorks data warehouse. Go ahead and run that. And that will just bring it back to its default setting that we would have used in previous modules. So if you look here, that the two tables in question, dim products and dim customers, do not have any slow changing dimension columns other than the customer key and product key, which is surrogate keys. So those are indeed used in slow changing dimension, but they're just ubiquitous in the design, data warehouse design. Now what we have to do is we have to go on and add on some other columns. And to do that, I've got this partial answer. We're going to go through that right now. So before I go any further, I'm going to make some changes to the source database. So in the source database, the customers table has, actually, let me set this back. Customers table has a customer 1100, so first customer in the list here, as John Yang. And this code here actually just sets it back to its default setting because I'm going to make changes to the data as part of the demonstration. And at this point, the customer's dimension table is currently empty, and you can see there's just the column country region name at the end of the column listing. But I'm going to go ahead and make that change now. First of all, I'm going to do is I'm going to modify the customers table. To do that, I'll drop the foreign key constraint and then drop the table. Can't drop the table with a foreign key constraint in place. And here's the changes I'm going to make. I'm going to add these three columns: start date, end date, and is current. Start date and end date, of course, makes perfect sense. End date is not strictly necessary because if you look at one row and it has a start date for one customer, and then you look at another row and it has a start date for the same customer, you can assume that the start date of the second entry is the end of the first entry. But having an end date column is kind of common, and it's considered a nice to have feature. Is current is going to be the same thing. You don't really have to have is current, because if I have a start date and then I have well, actually, let's just say I have the start date. The one with the highest start date is the current one. If I do have start date and end date, the one with the null and the end date is the current one. So once again, it's not necessary, but it is nice to have. And these are the common columns that you see. So once I make this table, I need to figure out how I'm going to fill it up with data. Here's this is one way to do it. I'm going to go ahead and use a very simple way. Well, it's not very simple, but it's simple to kind of understand. And I'll isolate the insert by using the except option here. So I'm going to figure out which IDs are in the source table, customers, that's not the destination. I get this list of IDs. Once I have that list of IDs, I can bring the data from customers into dim customers. Now, customer key is autofill, so that's the incremental identity option. And these columns, these are the new ones I've added. So the code will look something like this. Give me the customer ID. Oops, let me kick that over a little. I guess that's right. Give me the customer full name, customer city, state, province, country, all that stuff. But in the start date and end date, I'll go ahead and get the current date, the a null value, and is current. Now that would be a typical way to grab the data. So when it comes in, can't run it by itself because it's pulling from this common table expression, CTE. So when it comes in, I'll run this. 18,000 rows get made. And now if I look at the two tables, they are in sync. Now if I run that again, it won't flush and fill. It will just load up anywhere new IDs are in the source table, but not in the destination table. And there are none in that category. So everything is synchronized at this point. So that's really, really quite easy. Now, from the very first, we created the AdventureWorks basics, and we did the flush and fill where I dropped the foreign key constraints, truncate all the tables. Notice that I'm not doing customers in this case. And then fill it up with fresh data. Now notice that this is the products dimension, and it does not have, oops, or let's see, 7.6. It doesn't have the slow changing dimension columns. So that's part of what you need to do. You need to go ahead and make that up. Now you can use a different technique than the one I'm showing you. But if you want to use the same technique, that's fine. You can use the same kind of code and make things and change things. That's what this video is about, to make it a little bit easier for you to get the job done. I'll go ahead and fill up some dates here. Notice I've got the date range is 2005 2010. That's because those are the ranges where the current data from AdventureWorks Basics is at. It's all happening between those years. So I'll go ahead and fill up the date range. If you don't fill up within that date range, it won't work correctly. I do have some lookup values for date ranges of 1900, first day and the second day. And these, of course, are my ones that are describing the either a missing value or a corrupt value. You know, that doesn't look very good. This should be date, name, weekday, date and process. Tell you the truth, that's a full date. Okay, that's fine. Full date name. That's fine. This one actually should just be like NA. Not applicable, and this one should be like corrupt. You know, I always find something new. Now, when I give you I'm going to give you the script so you guys will have it, and it'll be my updated version. Okay, so now that I have that, it's time to work on my fact table. So I'll go ahead and fill up the fact table with data. Excellent. Put the foreign key constraints back on. Beautiful. And now all my tables are filled. Now, the fact table, the date table, and the products table currently are using flush and fill. The homework assignment is going to be, I want you to modify dim customers and dim products to do slow changing dimension. And then you can just flush and fill the fact table and dim dates table. The AdventureWorks basic here, I'm going to go look at the data. We're going to make some changes. So currently John is spelled Jon. I'm going to modify that to be John. And now we'll see that it's out of sync. So we're going to figure out how we're going to do this. Transfer. We'll create a CT that refers back to our code. What we're looking for is not just a list of IDs that have changed. That's what we had before, but any of the data that may have changed. And to do that, I need to do something like this. I have to concatenate the values. In other words, when this select runs, it's going to look at not just the IDs, it's going to look at the names. And this will allow me to do an update. So what we did is we flagged that the original one was no longer current, and we put an end date. And yeah, I could have done get date there. But now we got to go ahead and do the actual insert for the second row. And it's the same code as before. We'll just do an insert based on the customer ID. And you'll see that here I have my start date, I have my end date, and it's current. Start date is on the same day that it ends. End date, of course, is null, and it is now the current record. So now when I look at this, you can see that I have two rows. One is customer key 1, and the other one's 18,000 and change. But their customer IDs are the same because it's the same customer. It's just that their data has changed. So the process is two-step. You have to go through and modify the end date if you use this so that it has the date that it starts is the date that it ends. 0 becomes 1. Okay, so if I place an order, now notice that this is the day after that change happened. When I insert the data into the sales orders table, let me get that up and going. We'll look at this. First of all, in the source database of AdventureWorks, I should make a space here. You can see that it shows up as John with uppercase John. Placed an order. The brand new orders, I just kept it simple. I put a hard-coded value of 1 here. So, and I was too lazy to figure out some credit card numbers. So this is indeed the order on that particular date. If I go back over here and look at the customer record right now, we do have the new customer, but what I don't see yet is I don't see that sales order because we haven't synchronized it yet. So what I'm going to do is I'm going to go ahead and do the flush and fill, which is delete all the data from the fact table. And then I'll insert fresh data in. And this is the important part, as I have here. We have to make sure that when we bring the customer over, we're only going to get the is current record. The reason for that is we want that to be mapped to customer number, the newest one, 18,485, with the updated spelling. Now, the downside of this is that if I look back in history, where all of these entries were created, those those would have been made for customer JON instead of JOHN. But with the type 1, we just don't care. And that's what we're doing. We're doing a type 1 change on the fact table. So it's kind of simple information. They want to be called John. Now, historically, they were called John with an H. Now, if you wanted to, you could also apply the logic to the fact table and have that incrementally load as well. That takes a little bit more coding, and you don't have to do that for this assignment. So the reason why I'm not doing that is because I want to make it easier on you folks. I think the coding is going to be more interesting, as interesting as it needs to be right now. Now, this is not part of the homework, but for those who would like to see how the fact table can be worked with incremental loading, this example should help answer that question. Again, it's not part of the homework. But let me go ahead and set up a couple tables. I got a new customers table in the temp DB, and I've made this simpler, just 3 columns. I've got my dimension table, customer key column, ID column, name, email, and then of course the 3 columns for slow change in dimensions. Now I'm going to just go ahead and synchronize the tables with hard-coded values just for the demonstration. We have Bob Smith and Sue Jones as always. Currently they are the current records. I'm going to modify that though. I'm going to change Bob Smith to Robert Smith in the source table. Now that necessitates that I need to update the dimension table, setting the current row, Bob Smith, to is current 0, and let's say the end date is 2005. Originally it came in at 2000, so 5 years later he changed his name to Robert Smith. It's the same customer, so it's customer ID, and once we have that updated, we also insert a new value. Let's call it ID 300. Again, I'm hard coding this just to keep it simple. So now we have things set up where in the dimension table, the source has changed from Bob to Robert at some point in time. And that point in time was 2005, January 1st. Currently, since 2005, January 1st, the name of that customer is Robert Smith. The customer ID is the same, of course, but the customer key is different. Now that everything's in place, let's set up an orders table. I have an orders table and a fact table. I don't have an order detail table just to keep it simple. And we'll put some sales in that orders table. Let's see here. The orders table is customer ID. So I got these. 300. Oops. Yeah, 100. 200. Oh, I'm sorry. I'm in the orders table. Those have to be 100, 1, 2, and then 1, 1. Because in the original table it's 1 and 2, but then in the surrogate key we bumped them to 100 to keep them separate. Okay, sorry about that. Let me go ahead and insert that source data. Okay, that makes sense. Now, we have been just selecting the data and inserting it into the table. If I go ahead and pull this data right now from dim customers to get the key columns to the original orders, that's how we have been doing it, we end up with an issue here. And this is the issue. I know that Bob Smith changed a name at some point in time. And that was the first day of January in 2005. But this order here happened, well, excuse me, happened on June 6th. In other words, On June 6th of 2005, the name Robert Smith was correct. However, on June 6th of 2005, the name Bob Smith was incorrect. That row, those rows 2 and 3 are incorrect. Those values are not correct. At least not for order 3. For order 1, it's not correct that the name was Robert Smith. The actual person's name at that point in time was Bob Smith. So in other words, this row is also bogus. Sue Jones doesn't never change, so that's not an issue. This issue only shows up when a change occurs. So we have 3 rows now of data that are incorrect. And it also ends up double counting our values. In other words, we can't just use the same code as we have been previously to make this work if we are trying to work with tracking the changes to the key based on the customer's name at the time a sale occurred. That's why in the flush and fill, I'm having you guys just flush and fill, that's why in the homework I'm just having you do a flush and fill so you don't have to worry about this issue. But let's say you wanted to. You'd have to modify the code so that it would go through and not only pick up the IDs to join it, but also filter out the dates. In other words, in dim customers, if the start date, which actually indicates what name it was, is less than the order date, that's an additional filter, less than or equal to. And you can see that we do get some less rows. So if I look at this, the order date was May 5th, 2000. And Bob Smith's record is June 1st, 2000. Well, certainly that is less than or equal to the order date. So that's a legitimate value. It's true that it's no longer the current record, but that's fine. This is what historically his name was. Sue Jones, again, doesn't have any effect on this because her name never changed. But when we get down to the second part here, we still see some double counts. So yeah, we had the filter helped us, but it wasn't sufficient. The problem is that this record has been assigned to order ID 3, and that's not correct. The other one, row 5, has got the same issue. That's what they have in common. In both cases, the isCurrent is set to 0. And we have an end date. So these are bogus. We just need to filter them out. To filter it, we will add on just a little bit more code here. So now we're going to use this filter. If it's the case that the start date of the record is less than the current order date. So this one's 2000 January, this one's 2000 May. So yes, this is less than this. And it's flagged as being isCurrent. Well, it's not flagged as being isCurrent. So that would mean no, we're not going to get that row. However, I've added on the OR clause here. If you've got an end date, and the end date happens to be greater than the order date, now that is true. 2005 is definitely greater than 2000. And it's marked as being 0 in the incurrent, then that's good enough. So that row is legal, and to tell you the truth, that's exactly what it's supposed to be. So Jones not in question, so we go down to row 3. How about this one? Is this a legal row? Well, it turns out that the start date is or excuse me, the end date is greater than the order date. Or is it? Wait a second. Oh, no, that's not true. This is not the case. 2005 in June is certainly greater than 2005 in January. So it's not true that end date is greater than order date. It's the other way around. And because of that, this row goes. The next row, if we have Robert Smith, this is actually fine. The is current is set to 1, and it's also true that the order date in June is greater than January. So that matches on this clause. Line 5. This is a bogus record, but we capture it because of the same logic as before. Is current is set to 0, but it's not true that end date is greater than order date. Once we have that filter, all the records that are bogus go out. Now that we have this, all we have to do is just perform a update if we want to do an incremental load on the fact table, making sure that anything that had changed would be updated, and an insert for anything that was new. In this case, the ones that are new are these guys right here. So, and tell you the truth, would there ever be an update? Nope, actually there wouldn't be an update. We just add new rows in because we're tracking the changes. So we just have to insert the stuff that is new in there, and we can just do that with a simple accept. Be aware that that is not part of the homework. Let me put a note here. Note: the fact table can stay a type 1. Come on. And use flush and fill. So that way you guys don't have to worry about that. If you want to mess with it, you can, but you don't have to. So that should give you everything you need to get the job done. You still want to use stored procedures. You still want to use views. So you'll have to make some modifications. And you'll want to do customers and products. So I should give you pretty much everything you need for customers. No view code or stored procedure code, but almost everything you need. And then you just have to apply the same logic to products. Flush out the fact table, fill it up with the new data. The fact that if the names change, I don't care. I'm just going to go ahead and keep the older names. Oh, excuse me, the most current names. That's fine with me. I don't think our customers are going to complain. And if we change the name of the product, again, I'm not tracking that. It's not the best solution, but it is a solution, and it should make it so that your homework's a little bit more approachable. Once that's done, you just have to write a paper. The paper is to highlight the differences between using SSIS and SQL programming. Now, I'm showing you a SQL programming solution here. You could try to use Microsoft's slow changing dimension data flow task if you wanted to. But that's just an option. Or you could use the code that I showed you. What you want to do, of course, is make sure that you have the, once the script is made, you have the stored procedures, go ahead and do the same thing as before. Make it run from SSIS. So, note, fact table stays 1. You need to use stored procedures and views, and you need to use SSIS to complete the ETL process. Now, what I mean by that is you can either use like the slow execute SQL test, or the data flows. That's going to be your choice. I think that'll do it. I think that gives you everything you need to make this work. I'm making this video because this is a very difficult one, but with the inclusion of this, I'm hoping that everybody will be able to do it successfully, and I'll be watching the discussion group to see where people are at. Okay, that's it for this very, very long video, and I will talk to you later and look forward to seeing your homework. Take care.